Yeah, so today we're basically going to be talking about how you can use offensive security in the cloud to improve your cloud security strategy going forward. So we're going to be touching on a couple of things. We're going to be talking about the current state of the art of cloud security, as well as then some methodologies and implementations for how you can improve your cloud security with offensive security. So regarding the cloud computing has been around for a while now, but the truth of the matter is that when AWS launched around 20 years ago, they made a lot of promises about security, optimization, scalability, speed, and a whole bunch of other things. And the reality of this is that not all of these promises have come true. Cloud isn't necessarily as fast, scalable, or secure as the providers would have us believe. However, the cloud computing does come with a number of strengths that businesses have been able to leverage, and leveraging that agility and scalability across the modern tech stack has improved business operations in many ways. This does come as a double-edged sword, though. As part of this, organizations are essentially having to wage a constant battle against the process of cloud sprawl, or the process of managing the constant expansion and changes being made to cloud environments. And ultimately, this has ended up being one of cloud security's most Herculean tasks, because the very things that make cloud appealing for businesses in the first place have also proved extremely difficult for security architects and tooling developers to navigate around. In this talk, we're going to essentially cover the state of the art of cloud security, and then we're going to pivot to some interesting case studies, both of which MWR has observed, and some public cloud case studies. And we're going to break them down and see how the current cloud security approaches of essentially posture management and misconfiguration auditing can be augmented by offensive security approaches in the cloud, and what that has to offer in a combined cloud security strategy. So, in the earlier days of cloud computing, a lot of the default settings within cloud configurations were questionably secure. So thankfully, this has been improving in the last few years. Cloud providers have definitely acknowledged this issue, and they've been taking proactive steps to move towards a more secure cloud baseline. And one of the good examples of this is how AWS in the past few years have modified the way that S3 buckets work. So public access is now blocked by default. So now, with this in mind, similar changes are being enacted across multiple cloud environments, and we are moving towards a better, more secure cloud. However, despite these changes that have been made, we're still seeing cloud incidents arising from simple misconfigurations within cloud environments. And this is ultimately having serious real-world business impact on those businesses that are involved. Clearly, somewhere, something is getting lost in translation over here, because if secure defaults are getting better and we have a decent understanding of default misconfigurations in cloud environments, then why are we still seeing the same mistakes being made over and over again? Ultimately, we now need to understand what the missing link could be here. So earlier we briefly touched on how the scalability and agility of cloud environments, being one of its greatest strengths, is also some of the biggest weaknesses for security. And I think in cloud there's no greater area where this is displayed than IAM, or identity and access management. In the cloud now, providers have invested significant amounts of time and effort into improving IAM and designing granular and sane IAM solutions that supposedly have learned from the mistakes of legacy on-prem environments and IAM solutions such as Active Directory. John Lambert, a distinguished engineer at Microsoft, was famously quoted for saying, "Defenders think in lists, attackers think in graphs." And this is a statement that defined the security posture of Active Directory for years. We've seen the vast majority of Active Directory exploitation essentially hinge on abusing and leveraging IAM misconfigurations or vulnerabilities to escalate privileges and ultimately compromise domains. But have improvements made by cloud providers really made IAM that much better in the cloud? When identity and access management starts to get complex in larger cloud environments with lots of resources and services that are starting to experience cloud sprawl, it's ultimately all too easy to allow inadvertent privilege escalation paths to creep in via second or higher degree object ownership of principals. As most cloud environments are also rapidly changing and scaling according to business requirements, the likelihood for human error to propagate through increases, either as a result of not foreseeing all the possible consequences of enacting changes, or ultimately forsaking security for convenience. In an effort to broaden and bolster identity and access management and make the split of cloud security responsibility very clear, the mainstream cloud providers have introduced the shared responsibility model, which is a model that we're all familiar with at this point. And there's two main points I think to consider here. And the first of these is that the split of responsibility between cloud providers and the customer is not always clear across the many and diverse services that exist in the cloud. Oftentimes, you get scenarios in the cloud where you have services that there's a discrepancy between what the cloud provider is responsible for and what the end user is responsible for. And this has the opportunity to then propagate into potential misconfigurations for environments. The second main point to consider here, and arguably I think the most important point here, is that there's been a blurring of internal security responsibility as a result of the rapid nature of development in cloud environments. If we consider older legacy environments where developments were conducted on-prem, you would have development changes being pushed on a weekly or maybe monthly basis. But in the cloud, this is no longer the case. We've reached points now where deployments are essentially being conducted daily or even hourly. And as a result of this, if we look at the older model of how things were done, it was a lot easier to segregate more granular permissions because at the end of the day, if you had developers, they would be responsible for developing. And then from this point onwards, if they needed something else done in the environment, like opening a port on a network or something like that, then they could then get in touch with the relevant teams that were responsible for that, and that change could go through an entire process and be enacted officially. In the cloud, this is no longer really that feasible, and the reason for that mainly is because of the rapid nature of changes. So because of the fact that developers need to deploy more frequently now and architects need to deploy more frequently, there's kind of a blurring of those internal responsibilities now where identities, especially in DevOps pipelines, simply have too many privileges that are associated with them. And this is a problem that cloud security is still wrangling with to this day. So on this note now, we're going to talk about the cloud tooling paradox and how the current state of cloud tooling is not where it needs to be. So essentially with cloud tooling at the moment, we have proprietary and open source tooling, of course, and both of these tend to be focusing on different things. So proprietary tooling is mostly focused on defensive security at the moment, and that includes stuff like security posture management, misconfiguration auditing, compute protection, and other types of defensive security. And then in terms of offensive security, that's more focused towards what open source tools are doing at the moment. We haven't seen as much innovation in the offensive security space with proprietary tooling as we have seen with open source tooling. And I think that's probably typical. But the main issue here is that there's a bit of a battle between proprietary and open source tooling in terms of maintenance, because obviously with proprietary tooling at the moment, there's a greater likelihood that the tooling is able to survive and be maintained through cycles of cloud development, because there actually is dedicated teams that are developing these tools. Whereas with open source tooling, that is not necessarily the case. There's a bit of falling behind over here as cloud environments continue to progress. So there's a bit of a paradox here where there's a lot of value that can be obtained by using these offensive security tools in the cloud, but they're not necessarily at the level of development where they need to be. Whereas the traditional approaches offered by proprietary tooling mostly also have value in the cloud, but don't offer the unique perspectives that are offered by offensive security tooling. So we're going to quickly talk about misconfiguration auditing, because that's essentially going to be the main focus of the defensive tooling that we're talking about today. And then we're going to move into a couple of our case studies. So of the defensive security approaches that are currently in use for cloud, misconfiguration auditing is among one of the most prevalent ones. And it's also a very useful and important task in cloud security, because the most significant gaps that exist in cloud security are often the result of misconfigurations. However, there are issues with this process. So misconfiguration auditing essentially captures a snapshot of a cloud environment in time and then just provides an indication of what misconfigurations may be present in the environment at that time. However, this is often a checklist-oriented approach that benchmarks the state of your cloud environment against specific predefined benchmarks like the CIS benchmark or others like that. And one benefit of this is that it's architecture agnostic. So you can take a misconfiguration auditing approach and essentially just deploy it into a cloud environment without necessarily worrying about architecture in most cases, okay? The issue with this approach, though, is that it doesn't necessarily give you the full picture of vulnerabilities or misconfigurations in the environment. And the reason for this is because misconfiguration auditing focuses on vulnerabilities in isolation and not in chains of vulnerabilities which could result in attack paths. So the problem with this essentially is that, as we mentioned earlier, attackers like to think in graphs. And sometimes it's the simple, lower risk misconfigurations that can be chained together to potentially achieve higher impact in the environment. And this is the kind of visibility that misconfiguration auditing doesn't necessarily give you access to. So let's have a look at a couple of case studies now and compare the approach taken by misconfiguration auditing with the approach taken by offensive security. And we can see where the gaps are kind of filled in here so that a combination of these two approaches can really benefit cloud security. So the first incident that I'd like to talk about here is the Football Australia breach, which was disclosed last year. So this particular breach occurred to two main security blunders. So the first of these was that the Football Australia organization had a bunch of player data and PII that was stored in a publicly accessible S3 bucket. Now that's nothing new. We've heard of incidents occurring like this in the past, and this unfortunately was a replica of that exact issue. Then an attacker was essentially able to gain access to that public bucket, and the bucket also had listing enabled, so it was extremely trivial for the attacker to essentially just exfiltrate all the data out of that bucket. So the second issue that was more prevalent here and significantly more concerning is that there was a set of permanent AWS access keys that were embedded in the website's JavaScript. So that was quite concerning because it was associated with an AWS Cognito instance, and essentially anyone could have just gone onto the website, viewed the source for the page, and pulled the permanent access keys out of the source. So that is exactly what happened over here, and ultimately it was discovered that these access keys had access to another 126 S3 buckets across the environment containing a vast array of data and personally identifiable information. So what can we learn from this, and where can we see where a misconfiguration auditing approach would take us here? So with traditional misconfiguration auditing and security posture management, you'd probably detect the S3 bucket being public, at least the initial one. The issue with this is you'd still have to go further and do manual investigation because there's obviously, of course, very legitimate use cases for S3 buckets being public. In this case, it wasn't supposed to be public, but the misconfiguration auditing approach would give you that visibility. However, it wouldn't give you full coverage of the IAM permissions and the vulnerabilities that existed within the IAM environment to allow this kind of attack to happen in the first place. Essentially, auditing would likely not have protected against the exposed access key and permissive IAM configurations. So while security posture auditing tools like Prowler they do go for and show you privilege escalation paths, they almost always focus on direct first-degree privilege escalation paths where one principal can directly modify another principal to achieve an objective in an environment. In terms of the exposed access key, the risk here didn't necessarily lie with not running a specific tool, because there are tools out there like Trufflehog, which is something we are going to be covering, that would allow auditing of DevOps pipelines or repositories for secrets. The issue here was more along the lines of their DevOps pipeline was fundamentally flawed to allow that secret to make its way through the entire pipeline and into production in the first place. So ultimately, we have a scenario here where the picture of the full attack here with misconfiguration auditing and traditional approaches is missing. And there's something else that we can add. We can add additional value here with offensive security tooling. So I'm going to go through a brief demo over here. And essentially what I did over here is I created a Football South Africa website where it has exactly the same misconfiguration as what happened in the actual incident. There's an AWS key embedded in the JavaScript for the site. And we're going to use TruffleHog now to see how we can easily audit this key. So I'm essentially going to download the contents of the website, and then we're just going to run TruffleHog on that. And you can see that it easily picks up the AWS key that was embedded in the environment. And it also does some verification to determine if that key is in fact valid, which it is in this case. So this is the kind of initial approach that we might take from a pen testing perspective, where we would have a look at the environment and then we would go on to do some evaluation over here for the specific secrets or things that might be present in the environment. And I think this is an approach that organizations can really benefit from. So moving forward then, I spoke about IAM earlier. So we can use tools like Paku, which is an offensive security red teaming framework, and we can then use that to perform some enumeration of the privileges that are present in the environment with those access keys. Because the thing with cloud is you don't necessarily always have access or visibility of what privileges are attached to your identity. So using red teaming tools like Paku, we can then perform a brute force attack, which essentially enumerates all of the IAM privileges attached to that identity. And what that's going to allow us then to do is understand where our position is within the environment and where we can move forward from that point. So right here, I'm about to run the IAM brute force privileges module in Paku, which essentially does what it says on the tin. It runs through a whole list of APIs in AWS, and it essentially performs a brute force attack to determine what privileges are present. Now, this attack did take quite some time to run, so I'm going to skip forward over to the next slide. So once we have determined what privileges are attached to the identity, using an offensive security-minded approach, we can then see what things we have access to in the environment. Now, there are other tools out there like CloudFox that can help us establish an inventory of the environment from a black box perspective. In this case, I'm going to run an inventory of the S3 buckets in the environment to determine what our identity might have access to. And you can see there, the text is a little bit small, I do apologize for that, but you can see over there that we have access to an MWR briefing bucket. And now we're going to use the keys that we discovered from the website to access the contents of the bucket and potentially exfiltrate further secrets or gain a further foothold in the environment. Now, the purpose of this demo is essentially to showcase the more in-depth look at the environment that you'd get from an offensive security perspective as opposed to a traditional misconfiguration auditing perspective, because ultimately you get to exploit and see attack paths in the environment that you otherwise wouldn't necessarily know about if you were looking at things from a broader perspective. So, the next incident that I would like to talk about here is the 2022 FTX breach, or as I like to call it, a lesson in terrible architecture. So FTX, as we know, is the cryptocurrency exchange which collapsed in 2022, and they had a number of observations that were made by auditors around the terrible state of the environment following a really bad security incident close to the end of FTX's lifespan, where over $400 million in cryptocurrency was exfiltrated and stolen from the environment. So auditors had three main takeaways from this, and the first of these was that there was absolutely no account segregation employed by FTX. So essentially what that means is FTX and their sister company, Alameda Research, had all of the resources associated to all of their compute resources and customer data all stored within one single AWS account, which means that if there was a compromise of that AWS account, the entire house of cards would essentially come falling down and the attacker would have access to data everywhere across that environment. Then the second of these is that crypto wallet keys holding billions of dollars in cryptocurrency were stored in Secrets Manager, and a lot of employees in the environment had the get secrets value permission in the environment. So plenty of employees could just access these wallet keys and just access the wallets. And the third of these is that there was ultimately nearly zero logging and monitoring in the environment, which means that they also had almost no capability to detect cyber threats. So if they weren't doing any logging and monitoring, they would also have no detection as well. So from a misconfiguration auditing perspective, this is actually a scenario that would really be beneficial to run stuff like security posture management and misconfiguration auditing, because ultimately, running tools like Prowler would detect a lot of misconfigurations within this environment and alert you of major misconfigurations that could be fixed. And in this point, in this scenario specifically, the environment was so badly architected that you'd essentially have to recommend a complete re-architecting and rebuilding of the environment from almost scratch to get to a decent point in security. But while misconfiguration auditing would be really useful here, there's still a bunch of additional value that we can add here with an offensive security-oriented approach. Because ultimately, misconfiguration auditing tools don't evaluate architecture in meaningful detail. And you have a lot to gain by looking at a cloud environment's architecture and specifically what improvements can be made to that architecture. So the other thing with misconfiguration auditing, and this ties back to what we previously mentioned, is it doesn't necessarily detect all IAM attack paths in detail. And I'm going to show a bit of an example of this here. So I replicated a mock FTX environment where I created a bunch of IAM identities that had access to crypto secrets that was stored in Secrets Manager. And then I introduced one or two privilege escalation paths here. And then we wrote this tool over here that essentially performs second or higher degree enumeration of the environment, and you can essentially map out the privilege escalation paths here from an offensive security perspective. So for those of you who have sort of experience in offensive security on-prem, this might look a little bit like Bloodhound output, and that's essentially the idea that we were going for here, where you can have a look at this from a more in-depth graph-oriented approach to try and think like an attacker and therefore close off the attack paths that do exist. So right here we have a couple of FTX employees, and you can see over here that FTX employee 3 actually has a second degree privilege escalation path that will allow them to access the secrets in the ETH wallet, despite them not having access to that secret directly, because ultimately they are able to assume a role and then create an access key for employee 1, which then gives them access to the wallet. Now, this kind of security or offensive security oriented approach is something that you won't necessarily get full visibility of with a standard misconfiguration auditing approach. And I think it's really important to consider the kind of value that this can add to your cloud security strategy. So now I just want to briefly touch on a couple of small minor observations that MWR has made. So this is not really on the case of incidents, but it's more interesting things that we've spotted in clients' cloud environments over the past few years. So the first of these was a misconfigured AWS Cognito instance. And for those of you who don't know Cognito, it's essentially a service in AWS that allows you to exchange a set of credentials from an identity provider for a set of temporary AWS credentials, which you can then use to access other parts of the AWS environment. So in this, we observed a client who had Cognito self-sign-up enabled on their instance, and that's not necessarily a problem in itself. It allows users to register and essentially self-register for access to that Cognito user pool. The problem with this, however, was that there was also an identity that was attached to the identity pool then, and when they were able to get credentials from the identity pool, that was misconfigured such that you could actually send mails using an internal mail address. And the thing is, this could be leveraged quite significantly for phishing, because you can imagine a scenario here where an attacker is able to gain access to this mailbox and then send very legitimate looking phishing emails from an internal mailbox to other entities or people in the environment. So the next thing that I would like to talk about there is just a very brief thing we observed in an Azure environment recently, where there was some rather interesting network security rules that were poked in a Azure environment storage accounts. Now, these storage accounts had access to quite a bit of client data, and we observed that one of the network or cloud engineers had added these security rules to the environment as a means of just more conveniently doing their job. And this is not necessarily on the level of a business-breaking incident or anything, but it is something to consider because it's a nice example of how cloud sprawl can actually get out of hand over time. Because you can have with the increased amounts of internal responsibility that entities have in cloud environments, you can have situations where they're performing actions like this, and unfortunately, this just expands the attack surface of the environment significantly over time if it's not reined in and managed properly. So the next thing that I would like to talk about here is essentially the misconfiguration auditing approach and the offensive security approach with regards to these two specific examples that I've just given. So misconfiguration auditing over here would essentially detect the Cognito self-registration, which isn't necessarily a problem, as I have talked about, but it would not necessarily detect the full attack path that results from that, and that would be actually interacting with the identity pool, realizing that the IAM permissions that are assigned to that particular identity are just too permissive, and then leveraging that for a full phishing attack. That's something you would only really get access to from an offensive security perspective. Misconfiguration auditing would be really useful here for detecting public storage buckets in this case, or public storage accounts in this case, but again, it wouldn't give full context into what the impact of that in the environment was. That would require a more manual touch and having a look at it from a more offensive security-oriented perspective. So looking at what we can do next now. So I think the next approach here for cloud security is to move beyond misconfiguration auditing. And I think purple team approaches have a lot of value here in the cloud. And that's essentially using a sort of adversarial approach where you combine the benefits that you've obtained from misconfiguration auditing with the benefits that you can obtain from offensive security practices in the cloud. And ultimately, the goal of this needs to be to move towards better architecture, because architecture is extremely important in cloud environments, and I think moving towards a well-architected environment is probably one of the biggest wins that you can ultimately have in a cloud security strategy. So this involves ultimately using risk-based testing, which is your adversarial purple team approach, to find and fix real points of architectural weakness. And the whole idea behind this is, yes, you get a look at your environment from a misconfiguration perspective, but then you also get a broader understanding and idea of how the environment is going to resist and be resilient against real attacks from the perspective of an attacker on the outside, completely black box, or potentially from an assumed breach perspective where an attacker has access to specific privileges and identities. And then you can have a look at what controls you can implement from an architectural perspective to kind of rein in the attacker's actions, because ultimately that is probably one of the best approaches. But this is not necessarily a new approach. Like, purple teaming is not a new thing. We've been doing purple teaming for many years at this point. So why haven't organizations started using this or integrated this into their cloud security strategy in the mainstream? And this is a really complex question to answer. And I'm going to try give you an answer here, but I don't know if it's going to be satisfactory to some of you there. But I basically boiled this down into 3 points. So the first point here is that a lot of organizations comparatively haven't been using the cloud for that long if you compare to their legacy on-prem environments. Most organizations have kind of moved to the cloud in the last 10 or so years, and I think that the security maturity there is still not necessarily on the level that it needs to be. And this is quite interesting because although the cloud is a relatively newish thing from this perspective, the vulnerabilities and misconfigurations over here ultimately stem and tie down to security issues that we've known about for a long time. It may be different from on-prem, but a lot of the issues are actually not that different. The second point to touch on here is tooling. So I did touch on this earlier, but tooling is just not on the level that it needs to be in the cloud. And offensive security tooling is definitely not on the level it needs to be. We don't really have good proprietary offensive security tooling options. A lot of it is constrained to the open source space, which is then limited by the support and development that those tools get from their authors over time. And offensive security is something that heavily hinges on tooling to be conducted effectively and save time in testing. The third issue here is ownership, and this, I think, ties to similar issues that Tina spoke about in his talk earlier, and ultimately that goes down to, at the end of the day, when you're implementing more complex security strategies like this, like adversarial purple teaming as a strategy, who takes ownership of that in a complex environment, and where do you actually begin to start implementing that? So right here, I want to talk a little bit about the well-architected framework and how I think the current state of cloud security is. So I think with the majority of cloud environments nowadays, we are looking at a curve like this, where the architecture is essentially trending mostly towards default, and then on one end of the curve, you have flaming disasters like FTX, where the architecture is just terrible. And then on the other end, you have really well-architected cloud environments where people have spent a lot of time honing down the security issues in the environments and designing them in an extremely resilient fashion that would essentially make it very difficult for an attacker to move around in. Okay? And ultimately, we've explored the benefits of offensive security in the cloud up to this point and how these kind of insights could potentially be used to improve architecture. But here we go. How do we actually implement this in a practical sense? Because it's nice to talk about this from a theoretical perspective, but how do we actually do this? Well, I've boiled this down to 3 steps. Now, the first step is mapping it out. Okay, and what that entails is essentially conducting your standard misconfiguration auditing and also examining the architecture of the environment for any potential flaws that might be immediately present. Okay, so this can take the form of running tooling like Prowler, or using your cloud-native application protection solutions, or even running tools like CIS benchmarks just to get an idea of where the state of the environment is at a baseline. From then, you can then go to proactively hunt for credential material. Attackers ultimately need credentials. That's the focus of pretty much any attack, is to get access to an identity that they can then abuse to do something nasty in your environment. So ultimately, attackers want credentials. So proactively hunting for credentials in your environment and auditing the areas where credentials might be stored, like databases, secrets manager, stuff like environment variables and repositories, is a really good start to this approach. So now you get an idea of where your environment is from a baseline. So you can then move forward to trace and threat model in the environment. And essentially this involves using your credential access to find attack paths that target critical assets. And the whole intent behind this is ultimately, at the end of this, you're going to have an idea of what attack paths are present in your environment and what architectural changes you can make to hone those attack paths down and close them off. So this can involve enumerating the environment using some of the offensive security open source tooling that we've shown so far. So things like Paku, the red teaming framework that I mentioned earlier, CloudFox, CloudBrute, these are all tools that can be used to gain a further idea of where the environment is from an offensive security perspective. And then finally, graphing out the relationships between identities. So there's some tools that are out there that do this, like PMapper, and AWS also has it also has its own native solution for that, an IAM access analyzer. But you can also go ahead and develop some custom tooling here, or have a look at what you can do from a custom perspective. And AI can help a lot with this as well. Stuff like using or leveraging Claude or ChatGPT to generate sort of micro tools that do specific things can help a lot with this kind of strategy. But then ultimately, the final step in this process needs to be attack, analyze, and architect. So that is carrying out the actual feasible practical attacks that are present in the environment, and mapping out those attack paths, and then documenting and observing any blockers that might stand in the way of those attack paths succeeding, either from an architecture perspective, or maybe the credentials don't necessarily have the correct privileges or access because of something like a service control policy that's implemented in the environment. So ultimately then, this allows you to determine where architecture can be improved such that attack paths can be cut off. Because often in these kind of environments, attack paths targeting critical assets tend to go through similar points. So if you can identify where those points are in the environment and conduct security operations on them to stop attack paths from actually progressing through those points, you can make a lot of advancement in your cloud security strategy that's not necessarily covered by the traditional approaches that we've covered so far. And hopefully this is going to result in us shifting the curve with offensive security in the cloud, where we're going to be able to use this kind of purple team approach going forward to improve architecture. And ultimately, hopefully the well-architected curve is going to look a little bit more like this in the future, where we have a larger majority of organizations being well-architected, and then a smaller majority of organizations tending towards the default or bad side of the curve. So ultimately, this is the goalpost that we need to be moving towards. And by leveraging the insights provided by offensive security tooling, we hopefully can move towards a better looking curve. Thank you.